Thanks, welcome all to Enlit. Pleasure to be here after Frankfurt last year. Interesting to be in Paris. Interesting to be in a city where lots of things are happening, and very happy to complement what Marianne was explaining on the challenges that we have today around grids. So one thing that is basically not to comment anymore, where I think there is a consensus, is that the energy transition will come with more usage of electricity. That's a fact. And there has been in the last 10 years an incredible focus on generation of renewable. That's where the focus has been. Basically, where we are all convinced now, it's damn time to speak about demand side and to speak about grids. Because there will be no energy transition if those renewables are not able to flow and serve properly the demand side. There needs to be for all of us a sense of urgency. There will be around those days some comments and some events, and by the way, very pleased to have the International Agency of Energy with us in this event, so that they can as well comment with reliable data what's going on. What's going on is obviously an acceleration of investment in renewable generation. Probably not enough, so still need to accelerate. Now we need to all be convinced that if we just do that, if we just invest in renewable generation, we will not meet the energy transition and we will not give the answer to the energy transition. And we start to see problems appearing. Problem number one, how do we look at the demand side? Marianne, you explained it very well. There is a lot to do at the demand side, first in terms of sobriety, second in terms of being much more chirurgical in the way we analyze the demand. Second thing, the more electricity is needed, the more grid we will need to flow centralized generation, including renewable, and to connect better this grid with the customer of the grid. That's basically where my presentation will be about. What are the main challenges? And I think they have been well illustrated. First challenge for a grid or a utility today is, of course, the output and the efficiency. So the output, because there will be more need for electricity, okay, that will substitute progressively fossil fuel. Data points here is around 1.5 to 2 times more electricity in a period of 10 years. Second thing, of course, we need to do that with a higher degree of efficiency. And we know that on the network today, we have an accessible pool of efficiency, which is the losses of distribution. The second thing, of course, is connect more and more renewable. My first slide was illustrating that there is already waiting renewable capacities that are today not connected to the grid. Everybody is saying we will invest 2 times more in renewable. So basically, we will have to connect renewable, centralized generation, and something that is new and we start to see at scale in Europe is decentralized generation. So renewable at the demand side, which is a complete transformation on the way the network was managed. Last but not least, and it's very clear in the way, Marianne, you present it, utility want to be a role model in sustainability. It's not just about delivering electricity, but is doing it in a more sustainable manner. And there is plenty of touch points that can be done on the network so that this network and utilities are basically showing the way in terms of sustainability. There is a set of challenges as well to make the job of grid and utilities pretty complex. First challenge that we all face in our profession, especially in Europe, is we start to see shortage of workforce around electricity. Let's face it, 10 years ago, being in electricity was not that fancy, right? It was not the most fancy place where you wanted to work. We believe today that in the future, it's really the place where new engineers, new commercial people have to develop because you have a lot of potential association, and I'll come back on that, on digital technologies and on technologies that allow more sustainable future, which is extremely appealing for new generation. Now, what we have difficulty is to train the people and be sure they come well-trained into the system of the grid that we have to manage. The second thing is the regulation. Interesting to see the regulation changing. Probably we could challenge the speed at which it is changing, but it's changing in the right direction with much more integration of the entire chain of energy between generation to the demand side, and it's an important point. Last but not least, the challenge has been mentioned, and I think many of you have seen or experienced this challenge. We have seen over the last 3 years supply chain tensions that are easing as we speak, but we have to acknowledge, especially in Europe, that we have to reinvest in some critical technology that are not today at the scale needed for supporting the entire transition. So where the solution could be and what could be the solution to any of those points. My main message here is to say, of course, there will need to be investment in hardware, in many things. But there is a huge factor of speed and efficiency if all the investment we are doing in hardware are linked with a clear digital roadmap. Because for utilities of the future, data will be at the center on the way each and every investment will be done. The grid of tomorrow will be as much driven by hardware than by data. And what I'm going to show you in a set of examples is that if you build a clear strategy around data, you are able to improve your output, improve your efficiency, manage better connection to renewables that by design are intermittent, and this will not change in the foreseeable future, and of course, reduce environmental impact, even calculate real-time your environmental impact, which today is not what is asked, but we can probably estimate that in 10 years, the carbon footprint of each and every company will be something that will be followed like financial performance in 10 years from now. So a few examples to illustrate my point. First, let's look at operational efficiency. And I'm not going to comment all the examples we have here, but we see that we have a set of examples that goes along faster power restoration, especially when you have hard climate event, okay? Second thing is, of course, the capacity to connect faster and manage faster a fleet of renewable, like wind farms, solar farms. SAIDI reduction, which is not something new, but using the data and using the right collection of data in the right context, we estimate we can even improve further the SAIDI reduction into experienced utility. And last but not least, we are looking today in the future at substations that could be completely virtual and that would be much more easy to engineer and to program and to adapt to the case on which they will be implemented. So one here set of examples around the usage of digital technology, moving from ADMS, which is of course very important when you manage millions of points for a distribution utility, into collecting the right data, analyzing the data, and bringing efficiencies based on those data. I'm going to go to my second point, which is extremely important and that generates a lot of discussions in many parts of the world, is now coming to Europe as well, which is what we call distributed energy management system, managing points, many points, that are what we call prosumer. Prosumer is sites that are producing and consuming, and that basically are permanently willing to exchange their energy data with the grid. Of course, in parallel of that, you have still to connect a lot of new renewable farms, and you can do that by basically pre-designing all your connection and your control system of those farms so that you accelerate the lead time of connecting those wind farms. I want as well to touch the topic of being exemplar in sustainability, changing, of course, devices of the network, which will be another 30-year journey for utility, but to be able to reduce the SF6 emission. Of course, using data to better manage the maintenance plan. What we estimate, and we start to have a set of data points, is that utilities who are basing their maintenance on data are saving a lot on planned maintenance, basically, and they reduce that drastically. So we move into a domain where data are used to direct the team to where they need to be directed. Okay, and I could go again on one more example, because of course, each time we have losses on the network, if the generation is not completely renewable, we have additional emission, of course. We can reduce losses of the network by the right implementation of digital. So I hope you're convinced that moving to digital in parallel of hardware investment is absolutely fundamental to prepare grid customer to the future in which we enter. 2 points that I want to touch in addition. With digital, you can as well simulate. That will be extremely important. Simulation on network on demand will become a key topic, and of course, connecting more demand-side customers, the famous prosumer that we will have in the future. That's only possible with digital. So I hope I convince you that there is a path towards more sustainability, towards more output to the grid, towards the reinforcement of the grid. This path is really a mix of hardware investment and digital investment. Thank you very much for your attention.